Hi everyone, my name is Vipul Saini and I am a student of Civil Branch 3rd year in SIT Pithoragarh College. So today I will explain about the pre-stressed concrete. Today I will explain about the pre-stressed concrete and the advantages of pre-stressed concrete over the RCC and PCC. So before I explain about the advantages and the meaningful effect of the pre-stress on our structure, it is necessary to discuss about the plain concrete and the reinforcement concrete. So first of all, the first one is in the earlier times our ancestors used the PCC. PCC stands for the plain cement concrete. PCC stands for the plain cement concrete. After that, in the modernization, there is a introduction of RCC, and nowadays from RCC we directly move towards the PSC. PSC stands for the pre-stressed concrete. So there are so many disadvantages of plain cement concrete over the reinforcement cement concrete, such as in the plain cement concrete we simply provide a concrete. We simply provide a concrete to make a structure. We not use a particular bars, iron bars or steel bars. So it means that the compressive strength in PCC is maximum, but the tensile strength is minimum, means zero. So during the earthquake or during the time of earthquake, the structure which is made from the PCC is not so useful. They can break due to the effect of the P waves. Okay. So after that, to save our structure from earthquake or to construct a mega structure, there is some advantage of RCC. Such as in RCC we provide the extra bars. The full form of RCC is reinforcement cement concrete. Reinforcement is the number of bars which will be provided in a particular beam or particular area. So the introduction of bars in the PCC is known as RCC. So in the RCC, the tensile strength is equal to the nearly equal to the compressive strength. So in the RCC, the total strength means the compressive strength and the tensile strength. Total strength is just double from the PCC. That's why we use the RCC nowadays so many. But there is another concept to construct the structure, such as by designing a structure from the PSC. PSC is the pre-stressed concrete. So what is the pre-stressed concrete? Pre-stressed concrete is a simple concrete, but there is an introduction of number of bars. These are not the iron bars, but these are the bunch of wire. We introduce the bunch of wire by giving the tension in a particular beam or particular structure, then PSC is made. So there are so many types of PSC, but we only discuss the two methods how to PSC is formed. Our topic is pre-stressed concrete. So how pre-stressed concrete is formed? How the structures in which pre-stressed concrete used, they are formed. So first one is the first method is the pre-tension concrete, and second method is the post-tension concrete. Okay, so in the pre-stressed concrete there is also biggest advantage over the reinforcement cement concrete. The advantage is that it makes the structure light in the compression where we are compared to the RCC. So the main advantage is that the structure is never failed due to its self-weight, as we see some cases in the RCC. So in RCC, so now there is a question that why there is need to make a pre-stressed concrete. The need is that if we are talking about the RCC, suppose it is a beam. Suppose it is a beam. In a RCC, the upper part is the compression and the lower part is the tension. The upper part, it is a neutral axis. So above the neutral axis, the part is called as the compression part, and below the neutral axis, the part is known as the tension part. So in RCC, there is a disadvantage is that in the RCC below the neutral axis, suppose it is a beam of concrete. So in a RCC below the neutral axis, there is less use of concrete below the neutral axis. That's why this part is only increasing the cell weight of the structure. Okay, that's why we provide some other concepts, suppose such as tendon or some other wire, which is called the pre-stressed concrete. So it is the main advantage of pre-stressed concrete that by introducing the tension in any structure, it can utilize the lower half part of any structure, such as if we are talking about the beam or if we are talking about any other structure. So PSC is utilize the lower half part of the structure. So in PSC, pre-stressed concrete can be made by two methods. First one is the pre-tension concrete and second one is the post-tension concrete. So pre-tension concrete means that we are simply see from the name of the topic, that is the pre-tension concrete. Pre-tension concrete means we provide the tension in the concrete before casting of beam. Suppose if we are talking about a single beam, so in a beam how we provide the tension, how we made the pre-stressed beam. So there are two methods. First one is the pre-tension concrete, second one is the post-tension concrete. So in pre-tension concrete, we provide the tendon or we provide a tension in a concrete before the casting of the beam. So it is the pre-tension concrete. And if we provide the tension to the concrete after the casting of the beam, it is known as post-tension concrete. So there are some differences in between the pre-tension concrete and also post-tension concrete. That the differences is that in the pre-tension concrete, the minimum grade required is M40. But in the post-tension concrete, the minimum grade required is M35. Okay, so we take an example of the pre-tension concrete. How the pre-tension concrete method is useful for making the pre-stressed concrete. So in the pre-tensioning, the tension is applied to the tendon before casting of the concrete. Suppose before studying about the pre-tension concrete, there is a need to explanation about the tendon. So there is a new term in the pre-stressed concrete is tendon. Tendon is nothing. It is a bunch of wires. It is a bunch of wires which is used in a beam to provide the tension. So tendon is a bunch of wires in which we provide the complete tension to the pre-stressed concrete. So there are two types of tendons. First one is the centric and second one is the eccentric. So first one is the concentric tendon. Or second one is the eccentric tendon. So in the concentric tendon are those in which, suppose this is the structure of beam, this is the neutral axis. So it is simply for the RCC. If we provide any tendon, means the bunch of wire in the neutral axis, then it is called the concentric tendon. This is the concentric tendon. Suppose this is the neutral axis if we provide the tendon below the neutral axis or above the neutral axis, but not in the neutral axis, but not in the center of gravity. If the tendon is passed through the center of gravity of any structure, then it is called the concentric tendon. But if a structure is not passed through the center of gravity of any structure, then it is called the eccentric tendon. So the distance between the neutral axis and the provided tendon is called the E, and it is known as the eccentricity. This E is the distance between the neutral axis to the provided tendon, and this E is known as eccentricity. This E can either be in the lower half of the portion or can either be in the upper half of the portion. Okay. So after that, it can also be used in the pre-tensioning concrete or as well as the post-tensioning concrete. So there is a need to learn about there are two types of pre-tensioning. First one is the linear, and second one is the circular. Okay, first one is the linear, second one is the circular pre-tensioning. If we are talking about the bridge, so we simply see the deck of the bridge. In the deck of a bridge, there is some depth. It is a deck of the bridge. So in a deck of a bridge, there is the linear pre-stress is needed, which we not use the circular pre-stress for the deck of any bridge or any flyover. So in the linear pre-stress, it is provided in bridge or in the flyover. But if we are talking about the circular pre-stressing, it is provided in the tower. Suppose if we are talking about the tower. So the shape of the tower is circular. If we are taking the top view of a tower, so in the tower we provided the circular pre-stress. It is provided in tower.